Natural causes of climate change. So, negative feedback loops. So, Earth systems are complex and interconnected. Now, changes in one system can cause changes in another system. We call this a feedback. So, a feedback is the reaction of one system to changes in another system. And these can either amplify or dampen the changes that caused it. So, a feedback that dampens changes is a negative feedback loop. And these basically return the system to its previous state. So, for example, mine runoff that turns river acidic can dissolve limestone. Sometimes we actually use limestone in correcting some of these issues. So, you actually put limestone around the mine drainage sites or along the stream banks, and that will help neutralize the acidity and returns the river to its normal pH. So, dissolving limestone can cause these acidic rivers and streams to return to their original pH. That is a negative feedback loop. Now, positive feedback loops. So, a positive feedback loop amplifies the changes to a system. So, if global temperatures decrease, more of Earth will be covered in ice and snow. So, snow has a, or snow and ice have a high albedo, so they reflect a lot of light. Reflecting light basically is going to reflect more energy back out into space. So oceans and land have a low albedo, so they absorb a lot of light. So more surfaces with high albedos means more solar energy is reflected into space, which further decreases temperatures, leading to more snow and ice. That is a positive feedback loop. So increasing the amount of snow and ice increases the albedo, so more energy is reflected back to space, which lowers the temperature further, which creates more snow and ice. Now, the opposite is also true, or the reverse of this. So increasing temperatures can create a feedback loop of melting ice and increasing temperatures, because you're doing the opposite. You're exposing more oceans and land, which have a low albedo, which then absorb more light, which causes the land and the oceans and the atmosphere to warm up, which basically melts more snow and ice, which exposes more oceans and land, and the cycle continues. We kind of see over here, this is a high albedo, so areas that are highly reflective versus a low albedo area, which are darker in color and will absorb more light. Now, volcanic activity. So volcanic eruptions release immense quantities of dust-sized particles. We call those aerosols. Aerosols can remain suspended in the atmosphere for several years. So once these aerosols end up in the atmosphere, they stay there for a while. And then aerosols block incoming solar radiation. So they tend to block radiation that's coming in. This can lead to lower global temperatures, because less sunlight means lower temperatures. We kind of see here. So in 1991, the eruption of Mount Pinatubo in the Philippines resulted in slightly cooler temperatures around the world for 2 years following that eruption. So we actually had these 2 years here of cooler temperatures following that eruption. And the effects of volcanic eruptions are generally short term, so a year or two, and then they kind of dissipate because those aerosols tend to fall out of the atmosphere either on their own or they're washed out by rain and stuff like that.